Alright, in this video you're reviewing how to add, subtract, multiply, and divide rational expressions, as well as solving equations and also simplifying what's called a complex rational expression. Sometimes they just call it a complex fraction. So we'll start with problem number 7 here, which is multiplying. Now, as it turns out, when you multiply fractions, you multiply the numerators, you multiply the denominators. However, you can try to simplify first by looking to see if there are any common factors, not common terms, common factors, top and bottom, that might cancel out, which means, of course, that you have to make sure that all the numerators and all the denominators are factored. Now, in this problem here, I'm going to go ahead and factor these two expressions, despite the fact that they're exactly the same. I'm going to go ahead and factor them out. The GCF there is a 9, which is p plus 9, and that's all over. Now, p plus 2 does not factor. That's as far as that one simplifies. Up here, I can factor out a GCF of 3p. Remember always to check for the GCFs first. If I factor out a 3p, like reversing the distributive property, I get 3p times the quantity p plus 2, and just like this numerator up here, this denominator factors to 9 times the quantity of p plus 9. Because once everything is factored, you look to see if you can simplify this expression by canceling common factors that are in the numerator and the denominator, whether they're in the same numerator and denominator of the fraction or if they're in different fractions. I can cross-cancel a 9 here and a 9 here. Those are factors. I can cross-cancel p plus 9 with p plus 9. Notice I'm leaving them ones there to remind me that all that's left is a factor of 1. I can also simplify the p plus 2's, I shouldn't say simplify, but cancel them out as a factor of 1. So that's everything in the denominator has been canceled. So I have 1 times 3p times 1 is 3p all over 1 times 1 times 1. Well, of course, that's just 3p, and that's what that simplifies to. Now, if they ask you for restrictions on these expressions, you're going to want to take these denominators and set these denominators equal to 0 and see what values make any of the denominators equal to 0. Like here, if I set p plus 2 equal to 0 and subtract 2, I get a restriction. I get p cannot equal 2. Over here, if I set 9 times the quantity p plus 9 equal to 0, well, 9 can't be 0, but p plus 9 could be 0. If I subtract 9, I get p is equal to negative 9. So my restrictions would be p cannot equal negative 2 nor negative 9. Those would be the restrictions if they asked for that. They didn't ask for that in this particular review, but you never know. I saw some like that in your assignments previous to this. So that's how this first one works out to. Now, in the word problems, for every example I did, there was another one that was almost identical to it. Well, that's not the case here. As you can see, problems 7, 8, 9, and 10 are all different kinds of problems. This one's multiplying, this one's dividing. Although these are very similar, just like the adding and subtracting problems are very similar in their steps. So I'll go over here to problem number 8 next. And just like I did here, I'm going to factor all my numerators and denominators at factor. But remember, when you divide by a fraction, you are multiplying by the reciprocal. A over b divided by c over d is a over b times d over c. So you'd have to be careful there to invert and multiply. Now I'm going to do that in this next step, but at the same time I'm inverting this divisor here, I'm going to start factoring my numerators and denominators. This is n plus 10 times n plus 5. This is just n plus 10. It does not factor, but you can already see something might cancel here. Times, notice, remember, I'm going to invert and multiply times the reciprocal. So this is now the numerator, and that factors to n minus 10 times n plus 1. And this is now the denominator, and this factors into n minus 10 times n minus 1. So what do I have here? Well, besides these two canceling out here and here, and these two canceling out here and here, I don't have anything else. Now, don't get carried away here. Those are not the same factor, and those are not opposites. There is an opposite trick that sometimes occurs, like if this is n minus 1 and this is 1 minus n. Those are opposites, and they would cancel with a 1 and a negative 1 if this was 1 minus n. But these are not. These are conjugates. They don't cancel. And n plus 5 up here doesn't cancel with anything. So I'm going to have 1 times n plus 5 times 1 times n plus 1, which I'm just going to write like this, unless the directions ask me to multiply it out using FOIL. 1 times n minus 1 is n minus 1. I'm going to leave my answer like that. Now this one also has restrictions, and I will just warn you that you have to be careful here, because not only do you have to check when this is equal to 0 and when this is equal to 0, but since you inverted, when this guy is equal to 0. So there would be all sorts of restrictions here. N couldn't equal negative 10, n couldn't equal positive 10 or negative 1, and here n can equal 10 or positive 1. Or I could write it, n cannot equal plus or minus 1 plus or minus 10. So there are some restrictions there. Again, the directions didn't ask for that. I just wanted to make sure and emphasize it. Now over here, I kind of like this problem. It's an addition problem. I like it because my denominators are exactly the same. Unlike multiplying and dividing, when you add and subtract rational expressions, you must have a common denominator. And I'm going to factor these guys because sometimes they simplify. I don't know if this one does. But when the denominators are the same, you add the numerators. So I'm going to put it all over that denominator, which is x plus 5 times x plus 6. And that gives me up here, see, I'm going to add all this to this. I'll go ahead and write the extra step. And that would be 7x all over the quantity, because these are going to cancel, all over x plus 5 times x plus 6. And that doesn't simplify, nothing cancels. You can't cancel this x with either one of these guys, because these guys aren't factors, they're terms within a factor. This guy's a factor, so is this guy. Nothing cancels top and bottom. That's as far as this goes. I do have restrictions here as well. X can't be negative 5 or negative 6. Now this guy here is asking you to subtract, and there's a little bit of a trickiness here to this problem, because the first rational expression, that simplifies. You could simplify this. 3 goes into 3 once, 3 goes into 6 twice, and these x's cancel out. I have 2 over 1 minus x plus 5 all over, now I'm going to factor that denominator, 2 times the quantity x plus 6, because I can't find an LCD if I don't have them in factored form. And the reason that this saves me a little aggravation is now those that 3 and that x, they're not down there anymore. They're not going to be part of my LCD. My LCD is this guy. Because anytime you have 1 and another denominator, that other denominator is your least common denominator. So I am going to multiply this first fraction here by 2 and x plus 6, top and bottom. So I just went ahead and emphasized that a little bit by writing that with the blue pen here, over 2 times 1, minus, this is x plus 5, all over 2 times the quantity x plus 6. Now over here, this 2 and this 2, right? That's 4, and it's going to be distributed, the 4 is here, is going to be distributed over the x plus 6. That's going to give me 4x plus 24 all over 2 times x plus 6 minus x plus 5 all over 2 times the quantity x plus 6. Be very, very careful. At this step, you must be careful because of the subtraction sign. A lot of mistakes are made because you are subtracting the entire numerator. So watch what I'm going to do. I'm going to put it all over the common denominator. I'm going to write the first numerator minus all of this, so in parentheses, x plus 5. I do that because I like to try to emphasize the fact that you're subtracting the whole thing. That's like multiplying by negative 1. So up top, I have 4x plus 24 minus x minus 5. It's like distributing by negative 1. That's all over 2 times the quantity x plus 6. Now, if I'm lucky, it simplifies a little bit, and I can see it simplifies by combining like terms. I get 3x, looks like plus 19, that's not going to factor, all over 2 times the quantity x plus 6. That numerator is not going to factor. There's nothing that cancels out. So that's your guy right there. And there is one restriction. Well, there's one restriction here, but there's a restriction here on the x. X can't be 0. And x can't be negative 6. Okay, now again, they didn't ask for the restrictions, just in case. I wanted to kind of go over that. And you have to be careful with the division, because not only is the denominator of the divisor considered for restriction, so is the numerator. Alright, these next 3 problems are all solving equations involving rational expressions. And I was helping somebody earlier today with a problem like this. And what you got to do is you've got to transform these equations and make them look like something you already know how to solve, like a linear equation or even a quadratic equation. So I am going to get rid of the denominators. I'm going to get rid of the fractions, and I do that by multiplying both sides by the least common denominator. Let me say that again. You're solving a rational equation. I'm not talking about simplifying rational expressions. There's no equal to in a number. I'm talking about rational equations where you already have it set up with an equal to and stuff on both sides. You don't just try to get a common denominator to simplify. You get a least common denominator to multiply both sides by, so that you will get rid of the fractions. Now look up here. M squared, 3m, 6m squared. The 3 and the 6, my LCD, would be, from that part, would be a 6, and I have 2 factors of m, 1 factor of m, 2 factors of m. So the most it's used is twice. Don't total them, it's the most times it's used in a denominator. I caught a real break on this because the denominators are all monomials. Monomials don't factor. I can just go right after my LCD. Now watch what I'm going to do. I'm going to take 6m squared and I'm going to multiply it on both sides. Times the left side. And on the right side. Be careful, on the left side you have to distribute. It's like over 1. Do you see how the m squareds are going to cancel? I'm going to get 18 plus, over here when I multiply, this times this, 3 goes into 3 once, goes into 6 twice, 1 factor of m with one of these factors of m, that's 2m, times 1 is 2m. Better check that out. That's a tricky part. Okay, I'm distributing, and it simplifies by cross-canceling when I multiply it times the 1 over 3m. On the right side, this also simplifies, but everything cancels out except for the 5. That's not so bad. Subtract 18 from both sides. 2m is equal to negative 13, divide by 2. M is equal to negative 13 halves. Now, unlike the story problems in the previous video, when I got a complex... I'm going too fast. When I get an improper fraction, rather than change it to a mixed number, I can leave this guy as an improper fraction. But, warning, on any equation, rational equation where you're multiplying both sides by something with the variable, you must make sure it's not an extraneous solution. Remember, the extraneous solutions, when you plug back into the original, gives you a 0 in the denominator. Well, my only restriction on my denominators up here was the fact that m could not equal 0. And that's not a 0. This is a good answer. But you go back and you check. If this is my only answer and it makes the denominator 0, then there is no answer. I cross that one off, I write down empty set. Alright, over to here. Now, as it turns out, there's only one denominator that's not a monomial. It's x minus 4, and that doesn't factor. So you have an x here. This is like 1 over 1. That's not going to change anything. And you have an x minus 4 here. That tells me that my LCD is x times x minus 4, times those, both of those factors together. So I'm going to multiply both sides of this equation by x and x minus 4, those two factors. So I have x times x minus 4 over here on the left side, and that would be times 1 over x. And then I have x and x minus 4 times the right side, and that would be times all of this, so in parentheses or brackets, 1 minus x over x minus 4. The left side, not so bad. This is over 1. The x's cancel, and I get x minus 4 times 1, which is x minus 4. On the right side, I do have to distribute. So I have x times x minus 4 times 1, which is x times the quantity x minus 4, minus, careful now, I'm going to multiply it times this. Do you see how the x minus 4's cancel? Not the x's, they're both in the numerator, so that would be minus x squared. Well, I don't need parentheses around the x squared because it's the only term and I'm subtracting it. X minus 4 equals x squared, distributing here, minus 4x minus x squared. Well, I thought I was going to have myself a quadratic equation that I was going to have to set up and factor, but look at this. When I combine like terms, the x squareds cancel. I have x minus 4 is equal to negative 4x. I'm going to subtract x. I get negative 4 equals negative 5x. I'm going to divide by negative 5 to get my variable all by itself. And a negative 4 divided by negative 5 is 4/5. Looking back. Okay, does 4/5 make this denominator 0? No. Does 4/5 make this denominator 0? No. 4/5 minus 4 is not 0. Up here my restrictions are x couldn't be 0 or 4. That's not either one of those guys. There's my answer. Alright, now it gets a little bit more interesting. At least I have a plus sign here, because I do have a denominator that factors. Now, being a kind of a lazy guy, I'm going to factor this denominator right underneath it before I start doing a whole bunch of steps. So I want to see what this factors into, and this is n plus 5 times n plus 1. Which is really nice, because look, it's the same two factors as the other denominators. That's my LCD. You see that? This factor's in there, and this factor's in there. So I am going to multiply both sides by n plus 5, n plus 1. Yeah, I'll put the times here. 1 over, and I'm going to write this in factored form, n plus 5 times n plus 1, plus 1 over n plus 1. Now, put your brackets in, or your parentheses, because you have to distribute this. And then on the right side, I am also going to multiply by the quantity n plus 5 times the quantity n plus 1. And this is going to be times 3n plus 2 all over n plus 5. This is getting messy. So I have to distribute here. Well, this times this, you can see everything cancels. I just get 1 plus, here the n plus 1's cancel, and I have 1 times n plus 5. Now normally I'd put parentheses there, but because it's a plus sign, I don't have to worry about my signs. And if I did put parentheses there, it's not like you notice it's a plus sign and you can just go ahead and get rid of them. On the right side, this gets a little exciting here. These cancel out, and I have n plus 1 times 3n plus 2. I'm going to have to FOIL. On the left side, I combine like terms, but on the right side, I get 3n squared plus 2 plus 5n plus 2. Now, this is a quadratic equation, and I'm going to have to solve this like a quadratic equation. With the linears, you just isolate the variable. But with quadratics, you get everything on one side and keep your fingers crossed that it will factor. If not, you have to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to subtract n and subtract 6. That gives me 0 equals 3n squared plus 4n minus 4. Well, if I'm lucky, this is going to factor, and I think it does. I think this is going to be a 3n and an n. Now you could do the bottoms up method on this one. Multiply by the 3 and so on, but I'm just going to do the trial on air. I'm going to go with 2 and 2. 2 here and 2 here. And I need a plus 4, so if this is plus and this is minus, I'm going to get it. Now, I'm going to get two answers. There's a possibility one or both of these answers is extraneous, so I want to make sure that it doesn't make any of my denominators 0. So I said each one of these equal to 0. Here I have to add 2. I get 3n equals 2. Divide by 3. I get n equals 2/3. Here I'm going to subtract 2. And I get n is equal to negative 2. So these are my answers right here and here, unless they make the denominator 0. Well, the only thing that's making my denominator 0 are negative 5 or negative 1. Same two factors. And I don't have those. Both of these are good answers. Don't forget to check. Now, there's 3 equations in a row, and they all have a little bit of difference to them. But the key step is factor the denominators if they factor. Find your least common denominator and multiply both sides by that to eliminate the fractions. Get something that you can solve, even if it's a pain. This guy is completely different. This guy probably should be over here with these guys because this is not an equation, this is an expression. And they want you to simplify this complex fraction within fractions, this complex fraction or complex rational expression. Now to do that, there's 2 methods. Method number 1, find the least common denominator and multiply the numerator and denominator by it. Method number 2, combine the stuff in the numerator, combine the stuff in the denominator so you have one fraction over one fraction, and then invert and multiply. Sometimes one method might be 1 or 2 steps less than the other. I don't think it's a huge difference here, but I do have a decent sized least common denominator because I have a 9, 3 goes into 9, I have a 5, that's 45, and 2 factors of m, that's 45m squared. So if I multiply top and bottom by, oh, well, I got to write the 5 down, 45m squared, I have to be careful, I'm distributing, so I go over 1, so 45m squared times 9 over 5m, the 5 is going to go with the 5 here, leaves a 9, one of the m's is going to cancel, I have 9m times 9, that's 81m, plus, alright here, go back to what I'm multiplying, the m squareds cancel, and I have 4 times 45, which is 180. Alright, looks like that's going to factor. On the bottom here, I have 45m squared times this mess, so 45m squared times 25 over 9, well, the 9 goes with a 9 here, that leaves a 5. So 25 times 5 is 125m squared. Plus 45m squared now times 2/3, 3 goes in that once, 3 goes in that 15, so that's going to be 30m squared. Well, I can certainly simplify the denominator because it looks like it's going to be like terms. So up top, if I factor out a 9, I get 9m plus 20. On the bottom, if I combine like terms, I get 155m squared. Well, 9 doesn't go into 155. This thing just doesn't simplify. That's as far as that one's going to go. There's your answer. Now, I worked this problem the other way where I simplified the numerator and combine, and simplified the denominators and combine, and then invert and multiply. It was actually a little bit more work than this one, at least the first time I did this. So you can practice either method, whichever one you like better, but make sure that you practice this stuff.